Come back, student. Now, today we'll discuss on different types of annealing process. Uh, Among them, there are various types of heat treatment process are there. We will discuss only today that annealing and normalizing. Okay. In the previous lecture video, uh, we already discussed on the introduction of basic heat treatment process. Introduction of basic heat treatment process, in which you already learned that what is heat treatment process and why it is necessary and what are the main function of heat treatment process and how do you select of heat treatment process and what are the different types of heat treatment process, and there are basic information regarding different types of heat treatment process. Now in this lecture video we cover that we already learned that the different types of heat treatment process like annealing and normalizing, and what are these procedure, and what are the phases that are basically produced in from different types of annealing process like full annealing, process annealing, spheroidizing, diffusing annealing, what is normalizing. So this type of topic will be covered in this lecture video. Now first we will start on that annealing. So annealing is basically important, a widely used heat treatment process. Okay, actually in this process what happens that it first of all in this heat treatment process first heating the material to the austenite temperature. Okay, heating the material to the austenite temperature and subsequently cooling it very slowly, in a way that it is very slow actually, and such cooling rate basically achieved, this slow cooling rate basically achieved by leaving the steel inside the heating furnace itself, heating furnace within the itself without any further heat input. Okay, without further any heat input, you can cool your the material or sample within the furnace itself. Okay, and because of that extremely slow cooling rate, the final structure that would be a coarse perlite. Now coarse perlite, from the iron carbon diagram you know that perlite is basically formed because of the form in the eutectoid reaction. Okay, in the eutectoid reaction at the temperature of 723 degrees Celsius and the carbon percentage at 0.8% carbon, the product was the perlite, and it is a lamellar mixture of ferrite and cementite. And you know that the perlite may be two types, coarse perlite as well as fine perlite. Now because of extremely slow cooling rate, the main final structure that would be basically coarse perlite. Now, and you know that perlite basically there are two types, basically fine perlite as well as coarse perlite. Now in this because of this is a slow cooling rate, this is produced the slow cooling rate, so that's why the perlite would be formed but in the coarse structure. Okay, or in you can say that coarse grain structure. Now from this annealing process what you get that, or you can apply when you want to improve the mechanical properties, like if you eliminate internal stresses, because it can achieve the all internal, it can reduce actually, or it can eliminate all internal stresses, reduce hardness, increase ductility and enhance machinability as well as refine grain size. So these are the mechanical, as you know that heat treatment basically done to improve mechanical properties. So this is very important for selecting any heat treatment process, because in annealing heat treatment process, it is basically it is possible, you can get actually all to reduce internal stresses, reduce hardness, increase ductility, because as it is the cooling rate is slow, that's why amount of perlite or amount of coarse perlite is very much high. So if the coarse perlite percentage or phase fraction is increased, that means ductility is increased because of the softness of perlite, right? And if the softness of perlite, if the softness property is increased, if the perlite property is increased within the material, that means it reduces the hardness as well as it reduces the strength, as well as it eliminate all internal stresses, as well as it enhance machinability also. right? So these are the mechanical property that you can improve by annealing heat treatment process, right? Now, uh, and you know that I think you know that the annealing process basically important process for heat treatment of steel, and there are basically four types of heat treatment or four types of annealing process are there. First of all, there's a full annealing. Second is process annealing, third one is periodized annealing, and fourth one is diffusion annealing. Now, full annealing is main purpose is that to soften the metal. Okay, in this for full annealing, main purpose to soften the metal, to refine the grain structure and to relieve the stresses. Okay, so this is called actually full annealing process, and it is done consist of the actually it is done of the steel in 30 to 50 degrees centigrade above the upper critical temperature. There are two critical temperature in iron carbon diagram. One upper critical, second one is lower critical temperature. It is done above the heating the steel above 30 to 50 degrees Celsius of upper critical temperature, right? So this is one most important information. And in case of process annealing, what happens that it is also sometimes also called low temperature annealing process. Okay, low temperature annealing process. Now in this process it is used basically to relieve internal stresses, because it increase the ductility, it decrease the as well as the hardness properties. So it is basically used for relieving internal stresses and set up the metal. Okay, and obviously they increase the machinability, as already discussed, that these are the point you can achieve, but depending on the defined function or procedure annealing process, there are four types in which all the points will be covered. Okay, now in case of process annealing, it's sometimes also called low temperature annealing. Actually in this process, the steel is basically heated. In process annealing, the steel is heated to a temperature below or close to the lower critical temperature. It may be generally in between 550 degrees Celsius to 650 degrees Celsius. But as you know that in case of full annealing, that is basically that with above 723 degrees Celsius, like that. So this is the difference between process and full annealing, and it is sometimes it is called, because the temperature is as it is slow, that is called also process annealing or low temperature annealing process. Okay, and third one is that's periodizing or periodized annealing process, that is basically used. It is basically used for high carbon steel which are difficult to machine. In this case, actually the this type of annealing process are basically used, and the operation basically in this operation are basically slightly above the, it is done that slightly above the lower critical temperature, in between 730 degrees Celsius to 770 degrees Celsius, and it is held basically at the temperature for some time, then cooled at slowly temperature at 600 degrees Celsius. And for this spheroidizing annealing process, that it improves the machinability of steel, that already discussed on that, and but lower the hardness and tensile strength also. And last one is basically is sometimes also called diffusion annealing or homogenization. It is very important for material concern, for any type of material homogenization or homogenized part. For diffusion annealing is basically done for ingot and large casting. Okay, it is used only for ingot for and large casting. And basically after diffusion annealing, basically the casting undergoes the full annealing to improve their properties or to refine. It is basically main objective to improve the properties, as well as to or you can say that to refine the grain structure. You know that, I think you all of you know that you can improve the mechanical properties of material by means of refining the grain size, and it is done, or it is actually it is possible to in the diffusion annealing process, or it is sometimes also called homogenization process. It is done actually in the for the steel at higher temperature around 11 degrees Celsius, 1100 degrees Celsius to 1200 degrees Celsius. Okay, and it is basically held depending on the section thickness of the object. It may be for 2 hours, 3 hours, or 4 hours. It may be 8 hours also, 20 hours also, depending on the thickness object, the thickness of the size of the material. You can select your the annealing schedule. Okay, for diffusing annealing schedule. Now these are the parts for annealing. So basically annealing is done within the furnace itself, and this is the slow cooling rate. The summarization part is the summary of the annealing process is that, and it is done in the within the furnace itself. The slow cooling rate, main product is coarse perlite, so that's why it produce increase the ductility, reduce hardness, increase machinability, and increase the defined grain size structure. And one more thing, that annealing, basically there are 4 types of annealing process: full annealing, process annealing, and process annealing called low temperature annealing, periodizing annealing, and diffuser annealing sometimes it's called homogenization annealing. And what is the temperature range of that? You can just remind yourself that in case of full annealing, process annealing, periodizing annealing, and diffusion annealing. Okay, now next we move to the next topic, that normalizing. Right now, in the normalizing, basically it is basically faster cooling rate in case of normalizing heat treatment process. Faster cooling rate is basically achieved used actually in case of normalizing heat treatment process, and this may be basically achieved by cooling the material in the outside the furnace, means outside the in normal atmosphere air, which is basically faster cooling faster cooling effect produced than the furnace within the furnace. So normalizing basically used for the faster cooling rate. Okay, and it is basically the cooling the heated specimen in the steel air. Okay, now because of the uses of faster cooling rate, the perlite structure is obtained, but this perlite structure is somehow different from the that produced in the annealing process, because of that in case of normalizing process, that is basically fine perlite for normalizing test, because that it gives you the small time, and it get the uniform fine grain structure of perlite. So that's why it is called normalizing heat treatment process, as it is the structure is fine grain size. So that's why it gives higher tensile strength and as well as hardness than what are possible by annealing. So it gives the higher tensile strength and hardness. Okay, then basically what are, because as the structure, as the grain size is refined, as the grain size is very small, so obviously the strength and hardness will be increased. If the strength is increased, the hardness will be increased, because of the strength and hardness both are proportionally in proportional limit, right? So if strength is increased, the hardness also increase. So from normalizing process, the material's properties will be that in case of strength and hardness, that will be higher compared to the annealing process. Okay, so this is the important point and this is the main difference between annealing and normalizing. Okay, and one more thing, that if you the mechanical properties that achieve through normalizing, okay, that what are the mechanical properties, that may be strain, the ductility, toughness, and any other types of that malleability, this type of machinability, this type of mechanical properties that you can achieve through normalizing process is basically depend on the thickness of the section. Okay, the thickness of the section. And in case of thicker object or section, the outer surface may be normalized. Okay, may be normalized, but the core will be annealed. Okay, for thicker section or object, if you want to if you want to heat treatment on particular object, like or normalizing, that happens that it may be possible that as it is the thickness of the object is very large. Suppose this is the thickness of the object, or it may be the thickness object or like that. So if the thickness of the object is somehow larger or thicker, then the outer surface of the object may be normalized, because the cooling rate is very much at least cooling rate is high compared to the annealing, and as it goes beyond the core section, the cooling rate will be decreased. So the, as you know, the slow cooling rate is achieved through annealing process. So for in case of normalizing process, if you want to the heat treatment of thicker section or thicker object, it may be possible that outer surface may be normalized or the core section would be annealed. That means the outer section is basically that normalized. That means basically hard, and compared to the core section, in case of core section, the softness property will give. Okay, this is all for normalizing heat treatment process. And you know that in case of normalizing process, it is basically, if you want to ask that what is the difference between normalizing and annealing, first of all is the quenching. First of all, this is the medium, cooling rate medium or cooling rate. In terms of cooling rate is very much slow in case of annealing. In case of normalizing, cooling rate is fast compared to the annealing. And what are the mechanical properties that can improve? That is the second important point. In case of annealing, the strength as well as the ductility will be increased. Sorry, strength will be decreased, but ductility will be increased in case of annealing. And in case of normalizing process, tensile strength and hardness both can increase, but ductility will be decreased. So so this is the important difference between the annealing and normalizing heat treatment process. So it is the important point actually. Okay, so this is the difference between annealing normalizing process. And now let's take a quiz on this topic. So choose the answer. So try to yourself to revise. So the first question is that the purpose of heat treatment is to. So this is a question. The purpose of heat treatment is to. First option is that the relieve the stresses set up in the material after hot or cold working. First option. Second option, modify the structure of material. Third option, change the grain size. Which one is, and any one of these? Which one will be right after within four options? Try yourself. Take time. I think you get. Okay. So I think all of you ready. Now the answer is any one of these. That means the purpose of heat treatment is that relieve the stress set up in the material after hot or cold working. It may be possible that modify the structure of the material. It also possible that it change the grain size. It may be coarse or it may be fine, depending on the fineness of the structure of the grain. It may be possible to increase the strength or decrease the ductility. So these are the property you can change through heat treatment process. So any of them it can be possible. So the option fourth will be right. Okay. Now second question is that normalizing of steel is done to. Normalizing of steel is done to, first option, refine the grain structure. Second option, remove the strain caused by cold working. Fourth option, remove dislocation caused in the internal structure due to hot working. And fourth, all of this. So answer will be option D. So refine the grain structure, remove the strain caused by the cold working, and remove the dislocation. Remove dislocation caused in the internal structure due to hot working. Okay, all of this will be possible through normalizing process. So this is the fourth option is right, and this one. So this is basically right option for D. Answer D is for 2. And the last question for today's class, that the temperature required for full annealing is hyper-eutectoid steel is, which one is right? 30 degree to 50 degree above upper critical, 30 to 50 degree below upper critical temperature, 30 to 50 degree above lower critical temperature, and 30 to 50 degree centigrade below lower critical temperature. So for full annealing, so try to yourself, the answer will be 30 to 50 degree above the upper critical temperature. 30 to 50 degree above upper critical temperature. Okay, so that's all for today's class. In the next lecture video we'll discuss on another different heat treatment process like hardening, tempering, tempering, tempering. So thank you very much for listening me and watching me, and goodbye.